NVIS 3302 ARD RoboGuy. It is capable of sensing environment using various sensor modules and acts accordingly. NVIS RoboGuy is a readily assembled unit consisting of FR4 chassis wheels with different sensor modules mounted on it. This machine is driven by DC motors which are powered by rechargeable battery. This NVIS 3302 ARD is Atmega 328P microcontroller Arduino-based RoboGuy. It is designed for users to start developing smart robot which is capable of accelerometer balancing, gyroscope angular velocity sensing, ultrasonic obstacle avoiding detecting, and distance measure and many more. This is a Zigbee for wireless control for your smart robot.
I'll tell about the connections and pins on this Arduino board. This is the USB programmer, this is the USB jack for connection, and this is the digital output pin, these are the analog input pins. This is the motor driver connections, and these are the ultrasonic connections. This IC is L2390. This IC for the Arduino board is A328. These are the battery input, and this is the power button for the Buggy. This is the USB jack for charging, and these are the PWM output pins. This is for the Zigbee module, and this reset button is for the Zigbee module. This one is for the Arduino board, and this is the clock of this Arduino board.
L293D is a motor driver integrated circuit which is used to drive DC motors rotating in either direction. It is a 16-pin IC which can control a set of 2 DC motors simultaneously. The L293D uses 5 volt for its own power, and external power source is needed to drive the motors, which can be up to 36 volt and drop to 600 milliampere. Now, what is the concept? The L293D works on the concept of typical H-bridge, a circuit which allows the high voltage to flow in either direction. In a single L293D IC, there are 2 H-bridge circuits which can rotate 2 DC motors independently. Due to its size and voltage requirement, it is frequently used in robotic application for controlling DC motors, including in Arduino projects. The L293D is also a key component in large motor driver boards available.
Sensors that we have used in our project, ultrasonic sensor. Ultrasonic sensor generate high frequency sound waves and evaluate the echo which is received back by the sensor, measuring the time interval between sending the signal and receiving the echo to determine the distance of an object. Its working is based on ultrasound. Now, as you can see, the sensor has 4 pins: VCC, trigger, echo and ground. So it has both transmitter and receiver. When trigger is given half pulse for 10 microseconds, the transmitter emits ultrasound and the timer begins, and the emitter sound and ultrasound bounce back to the receiver once it hits an obstacle and the timer stops. So basically we can find the distance of an obstacle by using the sensor. Then comes the IR sensor. Infrared sensor, the IR sensor. IR sensor is an electronic sensor that measures IR light radiating from objects in its field of view. IR sensors work by using a specific light. Sensitive detectors select light wavelength in the IR spectrum. By using an LED which produces light at the same wavelength as what the sensor is looking for, you can look at the intensity of the received light. When an object is close to the sensor, the light from the LED bounces off the object and into the light sensor. This results in a large jump of intensity, which you already know can be detected using a threshold. About gyroscope. Gyro sensors, also known as angular rate sensors or angular velocity sensors, are devices that sense angular velocity. In simple terms, angular velocity is the change in rotational angle per unit of time. Angular velocity is generally expressed in degrees per second. अभी मैं शुरू
This is a Zigbee module named XB made by a company called Digi. The model we are using here is XBS2. It uses IEEE 802.14.5 Zigbee protocol to communicate. It uses 3.3 volt and has a similar pin spacing than most breadboards. It cases 20 pins and an antenna. It has 11 digital pins which are used for digital input or output and 4 analog input or output pins. It communicates using radio waves having an indoor range of 240 meters and a line of sight range of 120 meters. Zigbee can be set up to operate in two modes, AT and API. API stands for Application Programming Interface and AT for Transmit and Command mode. We will be using AT mode throughout the project. API mode is used when we are required to read or send digital or analog signals from external sensors. Now let's talk about how Zigbees can be networked. There are three roles which can be played by a Zigbee in every network, namely coordinator, router and endpoint. There is only one and only one coordinator in any network which is in charge of setting up the network. Router is which routes the data to different Zigbee modules in the network. An endpoint Zigbee cannot relay signals and may hibernate to save power. In the project we have used two Zigbee modules, one as a coordinator which is attached to the PC and one as a router which will be interfaced with the Arduino. Router receives the commands from the coordinator and the microcontroller on Arduino performs specific actions on receiving particular set of commands. It will be explained further how we put this to use in our project. We used a program called XCTU developed by Buggy to interface and connect Zigbee modules in the network.
The Zigbee. Now let's talk about the program related to the movement of Zigbee. So in a word setup we have taken 4 pin modes 5, 6, 7, 8 which is connected to the motors and these are set on the output modes, and serial.begin is used to set the baud rate between an Arduino and our PC. So there are different functions related to our requirement we have initialized, like void forward, backward, anti-rotation, clock rotation, stops and etc. So in a void loop we have initialized a variable s, and in a statement if serial.available greater than 0, it means that is any command is available or not which is coming from XCTU software for the Buggy. So s is equals to serial.read means that any command which is coming from XCTU software of from the coordinator Zigbee will be pasted on the variable s. And after that we just check the s. If s is this, then first of all we will make it 0 and it will, after that it will execute the stops command. In the same way, if s is capital A, then s we will once again initialize this variable so that we can easily rewrite the next variable. And for D it is clock rotation, for X it is backward, for W it is forward, and delay 100 is also taken because we do not want to overwrite any data, so it will give enough time to Buggy to read next data. So in this way the programming of Buggy with Zigbee is done. Thank you.
लेफ्ट लेना है, लेफ्ट थोड़ा स्ट्रेट ले, लेफ्ट कर दे, स्ट्रेट थोड़ा सा स्ट्रेट, लेफ्ट 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 लेफ्ट, थोड़ा सा सीधा लेफ्ट, स्ट्रेट स्ट्रेट नहीं नहीं, राइट राइट राइट, सही है, सीधे चल रहे, ठीक है, एक दो राउंड लगा लो।